welcome to today's Physical Sciences lesson. My name is Dimpo Rampora, and this lesson is brought to you by the Northern Cape Department of Education in collaboration with Kakama Research and Development. For today's revision lesson, we are going to be looking at Newton's laws, right? The following are the lesson objectives for today's lesson. By the end of the lesson, you should be able to define the normal force, friction force, static friction force, kinetic friction force. You should also be able to state Newton's first, second, third, as well as the universal law of gravitational acceleration. You should be able to differentiate between free body diagrams as well as force diagrams for objects at equilibrium and accelerating. You should also be able to define the resultant of two or more forces, and furthermore be able to discuss the importance of wearing a seat belt. Now, it doesn't stop there. You also should be able to calculate and solve problems using Newton's law equations. All right. Now that we have looked at our lesson objectives, we are quickly going to jump into our exam tips. What are the exam tips in this chapter as you prepare yourself for the final exam? Firstly, you need to know the structure of the paper or the framework of the paper. We know that Physical Sciences paper 1, you will be given 10 multiple choice questions, and then your structured questions will be about 130 marks. And altogether, you'll be writing a paper that is 150 marks for a duration of 3 hours. Now, the following are the cognitive levels that you will be expecting to see in your exam question. Now, there will be remembering questions that will require you to remember, questions that will test your understanding, applying, analyzing, evaluating, as well as creating. Now, the following are the knowledge areas that are in paper 1. It's mechanics, wave, sound and light, electricity, magnetism, matter and material. But for the sake of today's lesson, it is under the knowledge area, mechanics, all right, and which carries a lot of marks, by the way. Now, if you look at the structure of the question paper, it is normally question 2 of all the previous question papers that we are going to be dealing with, and it is normally plus minus 20 marks. Now, let us look at the exam tips in terms of the definitions that you must know. We've already said you must know Newton's first, second, third, the universal law of gravitational acceleration, defining the normal force, the friction force, the static friction force, as well as the kinetic friction force. Now, also, when you prepare yourself for your final exams, it's very important that you must draw a mind map where you can just memorize the things that you need to remember about that certain chapter. We've already said that you need to know about Newton's first law. What is it that must come into your mind? You must remember that F net is equals to 0. And here we are dealing with object at rest or moving at constant velocity. Newton's second law, we know that F net is not equals to 0. And we use F net is equals to MA to calculate our net force or calculate the mass or the acceleration. Newton's third law, we look at two bodies where we have object A experiencing a force on object B, and object B also simultaneously exerting the same force of equal magnitude in object A, but in opposite direction. So remember that, right? What is it that you must know about this chapter in terms of the common errors that we normally make? You always make the common error thinking that the constant motion is equals to a constant force, where many believe that moving objects require constant or continuous force, but this is actually wrong. We know that when an object moves at constant motion or constant acceleration, we actually mean that the force cannot be constant, but it can change even though the object is moving at constant velocity or constant motion. Zero force is equals to zero motion. This is not true because people think that there's no force and the object must be at rest, and this is actually incorrect, right? And then let me quickly go back here. Confusing the net force. The phrase no net force is often mistaken for no force at all. Remember that net force means that the sum of the forces that are acting on the object are equals to 0. Does not mean that there are no forces that are acting on the object. Now, more exam tips and more common errors made in this chapter is number one is converting units. It's very important that you must remember how to convert. If you are given kilometers per hour, remember that velocity is measured in meters per second. Okay, remember that. Failing to convert units properly, leading to the incorrect calculations. This is mostly a lot of common errors that you guys do. You are unable to convert from kilometers per hour to meters per second, and then when you do that, your answers will be incorrect. Now, number two is the sign error. You forget that when we are dealing with Newton laws, we are dealing with forces, and then forces are vector quantities that must have magnitude and direction. Incorrectly assigning positive and negative signs to forces and acceleration, especially in multidimensional problems. When you are given multidimensional problems, when you had to calculate maybe the acceleration or tension and you're required to solve simultaneously, most of you struggle there. Sometimes there is always a sign error that we get when we are marking this question. Omitting forces or adding non-existing ones. Incorrectly representing the direction of the magnitude of the forces. Now, this one, it is a very serious challenge that, you must remember that when you are dealing with Newton laws, it's very important that you always choose direction and you become consistent with that direction and include all the forces that are acting on the object when you are required to draw a free body diagram. Quick to conclude calculations, more worried about the final answer than the substitution. Remember that in physical sciences, we are interested in you copying the formula as it is from the data sheet and then substituting correctly. Then you can start manipulating the equation after you have done your substitution and then do your calculations and get to your final answer. But the final answer is actually 1 mark at the end of the question. But where do you get most of the marks? When you have written the correct formula and when you have done the correct substitution. Now, here are some of the exam tips that I'd like to give you when we are dealing with free body diagrams. Now, sketching of force of free body diagrams. You must be able to distinguish between a free body diagram and a force diagram. Remember that a free body diagram, you represent the object with a dot, while a force diagram, you actually draw the actual object and you indicate the exact position of your forces. Mark allocation is the guide to the number of forces required in the diagram. For example, the examiner might say to you, draw the free body diagram for the following, and then they say 4 marks. Then you must know that you must label 4 forces must be drawn as you are drawing either your free body diagram or your force diagram. Extra forces, leaving out arrows, arrows that do not touch the dot object or the object will result in the loss of marks. For example, if you are required to draw a free body diagram and you draw your arrow like that, as you can see, the arrowhead and the line are not touching, and because they are not touching, this will make you lose the mark. So make sure that the arrowhead and the line are touching to show that you are actually drawing an arrow. Label the forces correctly. This is one of the tips that is very important, especially when we are labeling a free body diagram. If this is a tension force, please use the correct symbol to represent that T is for tension, and also represent the correct normal force for capital letter N, and weight is small letter W or FG. Very important for you to use the correct labels. Now, let us look at more tips on how to draw the free body diagram. Please remember that if the examiner gives you a force that is acting at an angle, you must only include the component when starting with the calculations. Only when you start with the calculations, that's when you're going to draw the components. But if the examiner just says draw a free body diagram, please make sure that you draw that F as it is, okay, without including the component. That will be your normal force, that will be your weight or Fg, and then if that is a friction force, that can be either the kinetic friction force or the static friction force. So as you can see, if they say draw a body diagram for this one, for A for example, that is how you would draw it. And also when you are given an object that is acting at an angle, remember, please do not include the component. when you are drawing the free body diagram. So how will you draw it? Remember, you represent it with a dot. You always put FG going downwards, okay? Then you're going to have your normal force that must always act perpendicular to the surface, and then you're going to have that force F that is going to the right hand side, and the side you're going to have either your FK or your static friction force. All right, remember it must be parallel to the surface, okay? Never mind my drawing over there. Now, you do not include the components, I repeat, when you have vectors acting at an angle. You only include them when you are dealing with your calculations. Now, these are the different scenarios that you must remember to practice according to the exam guideline. So the examiner can either give you apply Newton's second law to verify equilibrium or non-equilibrium problems where you will be given a single object. Right, in a single object, they can ask you in terms of a moving horizontal plane with or without friction, moving on an inclined plane with or without friction, moving in a vertical plane where you have the lifts, the rockets, you must know how to deal with those different types of scenarios. But the examiner can also give you two body systems where they are joined together by a light inextensible string, and then you need to apply Newton's second law to do that. Now, you should be able to look at both on a flat horizontal surface with or without friction, on also one on a horizontal plane with or without friction, and the second one hanging vertically from a string over a frictionless pulley, both on the inclined plane with or without friction, and both hanging vertically from a string over a frictionless pulley. So you need to know all the scenarios that the examiner might be able to give you with this one. So on the flat horizontal plane, you might be given two objects like that. You also need to know how to deal with that. Okay, and then on the horizontal plane, the other one is hanging, so that means that you'll have another one there and then attached to the pulley, and then the other one is hanging. That is also another scenario that you need to be able to do. Another one is that you must also be able to look at when both of them are in the inclined plane. How will you be able to solve that problem? And then lastly, if both of them are hanging, that will be your pulley. One will be there, one will be there, and then both of your objects will be hanging. So these are all the different scenarios that the examiner can give us. So you need to be able to practice all of them. All right, now let's quickly move on to more exam tips in terms of Newton laws. The topic Newton laws, we already know that is assessed in paper 1. What did I advise you on already? I said you must copy the formula as it appears on the formula sheet without attempting to manipulate it first. You should also to ensure that you have the correct SI units. Very, very, very important when you are dealing with calculations. Show all your substitutions. Do not jump steps. We need to see all your substitutions as to how you arrived at your final answer. Include the correct unit for the answer. So you can use FSAUD to help you remember how to deal with Newton laws question or any questions that has that deals with vectors, right? You must copy the correct formula. You must substitute correctly. You must give us the correct answer with the correct unit and then indicate the direction where it's necessary. All right, that is very, very important. I hope this tip is going to help you. Now, these are the tips that I'm going to give you when you are going to be dealing with calculations or problem solving strategies that you need to use when you are dealing with Newton's second law or any other Newton laws. Firstly, you need to read the statement with an intention to understand the statement. That is very important. Make sense of the statement and preferably draw the diagram, draw what the statement is saying. It is going to give you a clear picture on what the examiner is trying to say to you. Draw force diagrams with all the forces acting on the object so that you are aware which forces you are working with. And then the direction in which the object or the system is going should be taken as positive. This is not always a must. It's just an advice that you can always take the direction of the motion as positive. And please be consistent with that direction. And then lastly, apply Newton's second law of motion, which would be F net equals to ma. Very, very much important to remember. All right, now that we have looked at that, now the last thing I want to give you is the tips on how to deal with multiple choice questions. First, you need to understand the concept, How do you do that? You make sure you have a solid grasp of Newton's third laws of motion. Understanding the principle behind each and every law will help you to eliminate the incorrect answer. So you should know the differences between Newton's first law, second law, third law, as well as the universal law of gravitational acceleration. That is going to assist you to eliminate incorrect answers. Read the question carefully. Now pay close attention rather to what the question is asking, and look for keywords in the question. Okay, keywords such as constant velocity, constant acceleration, frictionless surface, rough surface. Those are the keywords or phrases that you must look out for. That indicates which law or concept is being tested. That is very much important. Analyze the options that you are given, evaluate each answer choice, eliminate options that are clearly incorrect to narrow down to your choices. That is very important to go through. And then next, I want you to use free body diagrams for questions involving forces. Draw a free body diagram to visualize the forces acting on the object. This is really going to assist you. This can help you identify the correct answer when you are dealing with such multiple choice question. Check units and direction. You cannot stress this one enough. It's very important to check your units as well as your direction. Ensure that the units and the direction of forces or acceleration rather are consistent with the laws of the motion. Incorrect SI units and direction, or not being consistent with the direction, can often indicate a wrong answer, and this might lead in you losing the marks. And then 6, you must apply the laws. Know when to apply the law where. Use your Newton laws to solve the problem. For example, in the question involving acceleration, applying Newton's second law, where you use F net is equals to ma to find your correct answer, right? I hope these exam tips are going to help you. Now, it doesn't stop there. We continue with exam tip number 7 of multiple choice question. Consider edge cases. Think about the special cases or exceptional that might apply. For instance, if a friction force is negligible, if the system is in equilibrium. As I've already said, the examiner will use your keywords such as frictionless surface. There's no friction. Rough surface, you must include friction in your free body diagrams or in your calculations. Practice with sample questions, right? It's very important to say practice answering multiple choice questions. Use previous question papers to do that. Practice makes perfect. Work through multiple choice questions from previous question papers, online resources to get familiar with the types of questions that the examiner might ask you. And lastly, please stay calm and manage your time effectively when you are dealing with a multiple choice question. Don't spend too much time on one question, and then if you are stuck, just try to move on and come back to the question later. Maybe you might be able to answer it, all right? But lastly, do not leave multiple choice question unattended. You should never leave a blank space when you are dealing with the multiple choice question. Now, let's quickly move on to formula sheet. What is it that you must remember in this chapter? You must know which formulas to use when you are dealing with this chapter. We know F net is equals to ma. This one I use it when I'm dealing with Newton's second law. Okay, this is the formula that I use. I know Fs max US Newton multiplied by N. This is the formula to calculate the static friction force. Okay, friction force. And then over here, the moment I see a K, I remember that is the kinetic friction force. So this formula will be used to calculate the kinetic friction force. Okay, use the correct symbols. Do not leave out the subscript when you copy the formula rather from the data sheet. Okay, also Newton's second law in terms of momentum, that formula, and then we know that weight, or Fg, is equals to mg, and then that is the formula for the universal law of gravitational acceleration. Now, these all formulas, you need to know how to use them and copy them as they appear from the data sheet. Now we have come to the end of our exam tips. Now let us look at exam questions. Let's look at how to answer multiple choice questions. I have a multiple choice question over here. It says, two forces, F1 and F2, are applied on a crate lying on a frictionless horizontal surface. You know the keyword frictionless. You already know that we ignore rather friction. As shown in the diagram below, the magnitude of F1 is greater than that of F2. So F1 is greater than that of F2. Then you are given the direction over here, your east, west, north, and south. The crate will accelerate towards the east. Okay, so we want to know where will the crate accelerate. Now, if we say that it's going to accelerate towards the east, that means that it's going to the right-hand side. Now, it is not going to go to the right-hand side because F2 is less than F1. Remember, F1 has a greater force than F2. The crate will accelerate towards the west. Yes, this is the correct answer. It is going to accelerate towards the left, to the west. Why? Because F1 is greater than what? Than F2. Therefore, the object will be able to move in the direction of the force that is greater than the force that is opposing the applied force. All right. So B will be the most correct answer. All right. Let us quickly move on to the next multiple choice question. Yes, I already said that the answer is B. Let's move on to the next one. It says a net force F which acts on a body of mass M causes an acceleration A. If the same net force F is applied to a body of mass 2m, the acceleration of the body will be. Now, when you are given such multiple choice questions, the advice will be just to use the data sheet to answer the question. So go to the data sheet and just copy the formula F net is equals to MA, and then try to put in the all these that they've given you here to try to answer the question. So if you have done it correctly, you will see that the answer is what? Is B. All right. B is the most correct answer. We quickly move on to the next multiple choice question. It says, an object of weight mg hangs from a light cord passing over a light frictionless pulley as shown in the diagram below. As you can see from the diagram, we have mg and then we have the force there that is acting at an angle. What constant force F applied on the end of the cord as shown would hold the object at rest? So which one would hold this object at rest? Is it either A, F is equals to mg, B, F is equals to mg multiplied by sine theta, or F is equals to half mg, or D is F is equals to mg cos theta? So the correct answer is going to be A, because Fg is the force that will be opposing force F that will make mg to be constant, or would hold this object at rest, because the force and Fg would have been balanced. Or should I say that the tension force that is here and the Fg force would have been balanced. All right. Now we quickly move on to long questions. We are done with our multiple choice questions. We are quickly going to look at the long exam questions. Now we have over here question 7 that was taken from previous question papers. It says a 2 kg block is on a frictionless horizontal surface. Now, the first thing that I want you to do when you are dealing with a Newton's second law question, as you read the statement, you underline the keywords. We know that the word frictionless horizontal surface means that there is no friction, or should we say it means ignore friction. So we are ignoring the friction force. A second block of mass 1 kg is placed on top of the 2 kg block. There's the 2 kg block, there's the 1 kg block. Both blocks are joined by an inextensible massless string that pulls through a massless and frictionless pulley. Please bear in mind and read the question with understanding to understand what is the massless, what is the frictionless. It is the pulley. What is the pulley? This is your pulley that is massless and frictionless. As shown in the diagram below, the coefficient of kinetic friction force between the two blocks is 0.5. Remember the coefficient of kinetic friction, that is our UK, which is equal to 0.5. Then the first question says, state Newton's second law of motion in words. Very important that you must state the law as it appears on your examination guideline, which states that when the net force is applied on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. I hope you know how to define that and you have gotten it correct. Now let's quickly look at 7.2. It says, draw a labeled free body diagram for the 1 kg block. What did we say about free body diagrams? We represent the free body diagram with a dot. We look at the mark allocation. It's 4 marks. That means how many forces must we draw? 4 forces. Well done. So I'm quickly going to give you 30 seconds to draw the free body diagram, because it's either you know it or you don't know it by now. So quickly just draw the free body diagram for us and let's see if we can do it together later. Now, let's look at how to draw the free body diagram. That is how we should draw our free body diagram. The first thing that you are going to include is that we have the normal force. All right. Remember, the normal force, it is the force that is exerted by the surface on the object, and it must always be perpendicular to the surface. And then opposite to it, we have our Fg, or weight, okay, which is our force of gravity, or weight, which is always acting downwards. And then on the right hand side, we're going to have the friction force. But what type of friction force are we going to have? It is called the kinetic friction force, because the object is moving. Why is it going to the right hand side? Because the force applied in moving the object is going to the left hand side. So the tension force, which is holding the 1 kg block, is the one that is going to go to the right hand side, as you can see from the diagram that we were given. So that is how you draw the free body diagram. I hope we got it correct, and that is how you get your 4 marks. Now let's quickly move on to the next question. The next question says to us, how large must the applied force F be to give the 2 kg block an acceleration of 4.9 meters per second squared? So with this one, I'm quickly going to give you 2 minutes to go through it and try to do it by yourself and see if you can get the correct answer. Welcome back, learners. Now let us quickly do 7.3 together. Let's see if we have got it correct. Now remember, they are saying to us, how large must the applied force F be to give the 2 kg block an acceleration of that? So at the end of the day, we must have the acceleration of that, and how much force are we going to need in order for us to accelerate the 2 kg block with 4.9 meters per second squared. So what is it that you are going to do? So I'm quickly going to show you how I've worked it out. So the first thing you're going to do is to have work out the F net of the 2 blocks separately. So you will have the F net for the 1 kg block, where you are going to write F net is equals to MA, and then you include all the forces that are acting across the 1 kg block. And what do we have? We have the FK, we have the what? The tension force. But remember that FK and tension, they are going in opposite direction. It is very important to always choose your direction. So over here, I have chosen my right hand side to be negative. Because my right hand side is negative, that's why my FK goes in the opposite, in the negative. Remember, our free body diagram had FK going to the right hand side, and then we have tension going to the right hand side. We had the normal force, we had our weight, if you still remember. So this was the free body diagram for the 1 kg block. So that is what we are going to do. So that means here I have chosen my right hand side as positive. Why is my right hand side positive? Because I've taken the direction of the motion as what? As positive. So that is the first thing that I'm going to do. Then after that, what I'm going to do is do the same thing for the 2 kg block. I write F net is equals to MA. I'm not going to say acceleration is equals to 0. When is acceleration is equals to 0? When the object is stationary, or when the object is moving at constant acceleration or velocity. So again, what do? I draw the free body diagram for the 2 kg block. So from the 2 kg block, I know that I have, if I draw it quickly over here, remember you have the normal force, you have your weight or FG. Let's indicate FG over here. And then on the right hand side, you have your force A, which is the force applied. On the left hand side, you have the tension force. You also have the friction force. All right. So that is the free body diagram for the 2 kg block. So again, you are interested in the horizontal motion of the object because that is where the motion of the object is. So as you can see, I have the force A, which is positive because I've taken the right hand side as positive. If you look at how the object was like this. We have the 2 kg block. You have something like that. This is attached to that. Okay, let me quickly erase that. This is attached to that. Then for this to be able to move, this must move in that direction. That moves in that direction. So the direction of the motion in the 2 kg block will be the right-hand side. Therefore, my right-hand side will be positive. Remember that. So hence my FA over here is positive. I'm going to minus the FK because it's in the opposite direction and minus tension because it's in the opposite direction. This will be equals to MA. Okay, that is supposed to be small letter A. That is MA. All right. Now that I've indicated that, the next thing that I'm going to do is equate, okay? Make T the subject of the formula, which is what I've done here. I've made T the subject of the formula. Over here, I've also made T the subject of the formula. The next thing I'm going to do is to equate my two equations. After equating it, I can then now go to my substitution. From my substitution, I have included my substitution over there. And if I've substituted correctly, I'll get my FA as 224.5 newtons. Okay, very much important. Now someone can say, but why are you not including direction? I did not include direction because the question was saying calculate the magnitude. So if the question says calculate the magnitude, it's not necessary for us to include the direction. I hope you guys got it correct, guys, because this one was doable. Now let's quickly move on to the next exam question. This exam question, I'm quickly going to give you, this is easy stuff for you. I'm quickly going to give you 2 minutes to go through it alone, and let's see if we can do it together after that. Welcome back, learners. Let us quickly do question 6 together. It says 2 blocks of different masses are attached to each other via a light and extensible string. As you can see, there's the first block is 2 kg. The second block is the 5 kg block. T2, which is placed over a frictionless pulley. We have T2. There is our T2. What is frictionless? The pulley is what is frictionless. It is not the surface yet, okay? A block of mass 2 kg is placed on a rough surface. The moment I see the word rough, I know there is friction, okay? We are dealing with friction force. The next thing I need to figure out is the object moving or are the objects not moving, okay? And attached to the wall by a light string, which makes an angle of 70 degrees with the vertical rudder as shown in the diagram below. The second block of mass 5 kg hangs freely. The entire system is in equilibrium. When the system is in equilibrium, that means that F net is equals to 0. That means here we are dealing with Newton's first law. That means that these objects are stationary. There is no movement, all right, because they are at equilibrium. So here, what type of friction am I dealing with? That means here I am dealing with static friction force. Now let's quickly look at 6.1.1. It says, state in words Newton's second law of motion. Guys, we've already done it with the first one. So even this one, I know you got it correct. Newton's second law is when a net force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. I hope you got that one correct. 6.1.2 says, draw a labeled free body diagram for the 2 kg masses. Now, as you can see, the 2 kg block is over there, and look at the mark allocation here. I have 5 marks. That means how many forces must I have? 5 forces. So I'm quickly going to show you how I've worked it out. And then the next question asks us to calculate the magnitude of the tension force on T2. Okay, we are looking for T2. So firstly, let's look at how the free body diagram is going to look like. Now, the first thing that you must remember, I still have my 2 kg block. I have T2 that is going to the right hand side. There is my T2 going to the right hand side. I have my T1 acting at an angle. Remember, what did we say about forces that are acting at an angle? When you draw a free body diagram, you draw it as it is. All right. Then what else do we have? We have the static friction force, okay, which will go to the left hand side, okay, because if the object was to accelerate, we know that it will accelerate going downwards. That's why our friction is on the left hand side. And then we have Fg, which is already given to us all the time. And then we have the normal force, which is the force that is exerted by the surface on the 2 kg block. So that is how you would have drawn your free body diagram. I hope we got it correct, and that is how your 5 marks are distributed. The next question, we were required to calculate T2. Okay, if you look at T2, that is the simplest way to do it with the mark allocation, which is 3 marks. We were supposed to only use the 5 kg block. It's easy for us to calculate T2 there. Why? Because when you draw the free body diagram for the 5 kg block, you have T2, which is that one, and then which is this one, okay, and then you also have Fg, which is weight going downwards. So your T2 is equals to what? Fg, and Fg is equals to mg, and then m, what is the mass of the object? 5. G is the gravitational acceleration, which is the 9.8 meters per second squared. And then when you punch into your calculator, you should get the 49 newtons. All right, I hope you got it correct, guys, and I know you will get also this one correct. Let's quickly try to do this one also. I'm just giving you 2 minutes to try and do it on your own, and then let's see if we can get it right. Welcome back, guys. Let's see if we can answer this one. It's a continuation of our 6.1.3. We are continuing with 6.1.4. It says that the static friction force between the 2 kg block and the rough surface is 10.47 newtons. Then they say to us, show that the magnitude of the normal force exerted on the 2 kg mass is 5.58 newtons. So they want us to prove that the normal force is equals to 5.58 newtons. Where do you start? Guys, you already have the free body diagram for the 2 kg block. All right, what is it that you are going to do? You're still gonna say F net is equals to MA, and remember F net is equals to MA, and remember, because forces are at equilibrium, your acceleration will be 0. That will mean that you'll have 2 multiplied by 0, and 2 multiplied by 0 will give us the 0 there. That's why we have our 0 there. And then under F net, what are we gonna have? We're gonna have T1x, which is the component of what? Of T1. Remember, we're going to break down T1 into components, into Ty as well as Tx. Now, remember our Tx, we have the angle from the vertical, which is how much? Which is the 70 degrees. Okay, so what will happen to the 70 degrees? Then we must get the angle that is here. Remember, this is 90 degrees. And if this is 70 degrees, how much degrees will this one be? We know that in the triangle, the total of the angles in the triangle are equals to 180 degrees. So how will you get that one? Remember, we will say the 180 minus 70 and minus the 90 degrees. We must have gotten the 20 degrees. All right, the 20 degrees is the angle from the horizontal. That is what we put there as our cos 20 degrees. It's either you would have used cos 20 degrees, or you could have used a T1 sine of 70 degrees. So cos 20 degrees and sine 70 degrees is the same. Then you substitute the amount of friction that they've given you, which is that 10.47, and then you minus the T2, which you have calculated it in the previous question, which we got it as what? We got T2 as 49 newtons, if you still remember. Then you just punch in there, you put it there, and then the next thing that is left is for you to make T1 the subject of the formula and calculate. And then there you will get the answer as 41 newtons. All right. Then you take your 41 newtons, that is your T1. Now that you have your T1, you can quickly get your what? Your normal force now. Now, for me to get my normal force, what do? I look at all the forces that are working together with the normal force. I will have the normal force. I have Ty. I also have what? Fg, okay? Those are all the forces that are working together. So the Fn, which is the normal force, will be equals to T sine theta minus what? Fg, which is the T sine theta, which is the T of 41, which is that one, T1. Sine of 20 degrees. Why 20 degrees? This is what we got when we're looking at the angle from the horizontal, or you can use cos of 70 degrees. So here you can substitute cos of 70 degrees is still correct, and then you minus your Fg, which is the mass of the object is 2, and then multiplied by the 9,8. When we have done your calculation correctly, we should indeed prove that the normal force is 5,58 newtons as according to the question. All right, I hope you guys got it correct, because I know this one was very easy for you. Now let's look at 6.1.5. Now 6.1.5 says determine the coefficient of static friction between the 2 kg block and the rough surface. Now we are looking for the static friction force between the 2 kg block and the surface. What do? You go straight to our formula, which is Fs is equals to Us multiplied by the normal force. You already have the static friction force. We're given it in the previous question, which was the 10,47. And then what you need to do is you substitute the normal force that you calculated in the previous question, and then you should get the coefficient of static friction as 1,88 newtons. And remember, because the coefficient of static friction, it is a ratio, it does not have SI units. Remember, there are no SI units when you are dealing with the coefficient of static friction or coefficient of kinetic friction force. Now, what you must remember is that even if you got the previous questions incorrect, but you got the first question correct, you calculated your tension, your T2, and you got the incorrect answer, but you continued with all the steps with how we have done it. Remember that there is positive marking, that you must not give up, okay? Even if you don't know the answer, if you're not sure the answer is not correct, just continue with your calculations. Don't give up there. All right, let's quickly look at this question together. I'm sure you can answer 4.1 and 4.2 on your own. I know you already know the answers to this one. I'm going to give you 1 minute to do it. I know you'll get it correct. Welcome back. Let us quickly do this question together and let's see if you can get the 7 marks. You know, these 7 marks are free marks. All right. Now let's see if we can do it together. It says to us, a block of mass 1 kg is connected to another block of mass 4 kg by a light and extensible string. The system is pulled up a rough inclined at 30 degrees. Rough inclined, what you must come into your mind is that we already have friction. We just don't know if is it a static friction force or it's a kinetic friction force. To the horizontal by means of a constant force. Please, the constant is the force. It is not the acceleration. It is not the velocity. It's not the speed. Okay, it is just the force that is constant. So therefore, we can't say F net is equals to 0. Parallel to the plane as shown in the diagram below, the magnitude of the kinetic friction, already they say kinetic. We know that the friction that they were talking to here, the rough surface that they are talking to, is the kinetic friction force. We already know that the objects are moving. Between the surface and the block of 4 kg block is 10 newtons. So the friction force of the 4 kg block over here is 10 newtons. Then the coefficient of static friction between the 1 kg block and the surface is 0.9. So here you have your your coefficient of kinetic friction, which is equals to 0.29. All right. Remember, it has no SI units. Then they say to us 4.1, state Newton's third law in words. Remember, you need to know how to define Newton first, second, third. I know with this one you got it correct. We know that when object A exert a force on object B will simultaneously exert the same force of equal magnitude in opposite direction on object A. I hope we got it correct, guys. And remember, your definitions must be according to the exam guideline. 4.2 says to us, draw a free body diagram showing all the forces acting on the 1 kg block. As it moves, where is it moving? Up the incline. So the 1 kg block is moving up the incline. How many marks do I have? I have 5 marks. That means that I must have how many forces? 5 forces. So let's quickly draw it together. What is important? You start with Fg, or weight, going downwards. Remember, you do not include the components when you are drawing a free body diagram of an inclined. Then what we have there, we will have our normal force, which must always act perpendicular to our surface. You know, sometimes it would be very advisable that you can draw a line so that you see where your surface is. All right. From there, what else must you have? You have over there the force of 40 newtons. Your force of 40 newtons going up the inclined. Then down the inclined, what do I have? I have a string. That means I have a tension force that is going down the inclined. Not just the tension force, I also have another force that is going down the incline. And this force, remember, it must be parallel also to the surface, okay? Remember that force there is going to be your Fk. All right, so I hope you draw it correctly. Remember that you can make your dot bigger so that all your forces can fit if you don't see what's going on. All right, very important. That is how we draw the free body diagram. 1 mark, 2 mark, 3, 4, 5. Remember, if you add an extra force, or if your Fk was in an incorrect direction, if it was going up the inclined, you were going to lose 1 mark. Okay, you're going to be penalized for it. Right, guys, that's how you would have drawn the free body diagram. Hope you got it correct. Let's quickly move on to 4.3. 4.3 says calculate the magnitude of the kinetic frictional force between the 1 kg block and the surface. Now let's see how I've worked it out for you. You are calculating the kinetic friction force. You have already there coefficient of kinetic friction, which is the 0.29 that you were given from the question. You know the mass of the block, okay, which is 1. You know G is a given from the data sheet, is the 9.8, which is the acceleration. Then cos of 30 degrees. Why is it cos of 30 degrees? Because our normal force over here, our normal force is equals to Fg perpendicular. All right. Remember, you only include your this will be your Fg parallel. Remember, you only include your components when you are dealing with calculations. Remember, that's what I said to you. So your normal force here will be equals to Fg perpendicular. That's why instead of the normal force, we put Fg perpendicular, which is Fg cos theta. All right. That's why we have that cos of 30 degrees, because that is the angle of the incline, which is 30. Then you just punch into the calculator. You should get the 2.46 newtons. All right, guys, I hope you got all these correct. And then let's quickly look at the last question. I've already done it for you, which is 4.3.2. It says the tension in the string connected to the 2 blocks. We must calculate the tension in the string connected to the 2 blocks. So all the time when you are given 2 objects that are connected together by a string, and they say to you calculate the tension, and you don't have the acceleration, you must always use simultaneous method to first find the acceleration, then use the acceleration to calculate the tension. The first thing you're going to do, F net is equals to MA, copy the formula as it is, you get 1 mark. For the 1 kg block, you use your free body diagram. Do not forget the component of what? Of Fg, which is Fg parallel. Remember, your 1 kg block, You have over here FG parallel going down the inclined. You have over here the force of 40 newtons. You also have over here your tension force, all right? Remember, over here, you also have your tension force. There is your tension force there. Tension force. So these are all the forces that you must not forget. Don't forget to also choose what? To choose direction. Remember, you also have the friction force. Your friction force will also oppose the motion of the object. It should be somewhere there, all right? Then that's what you have over here under the 1 kg block. FA will be positive. Why is it positive? Because you are taking the direction of the motion as positive. The direction of the motion is going up the inclined. Therefore, up inclined will be positive. Anything that opposes up the inclined, that is going down the inclined, will be negative. That's why we have minus tension, minus the friction force, minus FG parallel, okay? Do not forget to input the FG parallel. Then all you do what? You equate your equation and make A the subjects of the formula. You do the same for the 4 kg block, but remember the free body diagram of the 4 kg block has changed. You have only the tension, you have the FG parallel, you also have the friction force. Remember, tension will be positive because it goes up the inclined, it goes to the direction of the motion, and then your FG parallel will be negative because it goes down the inclined. Then we have the friction force, which is the 10 newtons that we were given over there. Then you equate again, and then you make equation 2. Then from there you just equate equation 1 plus equation 2, or you can make T the subject of the formula, whichever way that works for you, okay? If you made T the subject of the formula, that means you'll say equation 1 equals to the equation 2. But because here we did not do that, we will say equation 1 plus equation 2. When we do that, we work out our acceleration. We get it as 0.608 meters per second squared. When you are done finding your acceleration, you take your acceleration, you substitute it either in equation 1 or in equation 2. Where there is acceleration, you put that 0.608 over here. So in any of those two equations, when you calculate the tension, you must get the same answer, which would be the 32.04 newtons. I hope you guys got it correct, and this takes a lot of practice. Make sure you practice so that you can be perfect. Now, thank you so much for joining in today's lesson. My name is still Dimpo Rampora, and see you again next time.